All right, I think on page 278. And I'm going to look at that starting at 11 through 22. Now they want the solutions and they want it on the interval from when they say, I'm going to do 12, they say 0 to 2 pi, and then they make this. So it's from 0, including 0, up to 2 pi, but not including 2 pi. And so they're going to want radian measurement. So sine x plus 2 equals 3. So what I would do is I would subtract 2 from both sides. And then you get sine x equals 1. And so what values of x for sine are going to be 1? Okay, but we have to do it in radians. So it's going to be pi over 2, and then it's all the way out to 2 pi. So is there any other places? Okay, so that would be the answer. And 14, and what I'm going to use is this algorithm on page 277, and those 5 different methods. Decide whether the equation is linear. If only one trigonometric function is present, solve the equation. If more than one trigonometric function is present, rearrange the equation so that one side equals 0. If the equation is quadratic in form but not factorable, use the quadratic formula. And then 5 is using identities to change the form of the equation. It may be helpful to square both sides of the equation first. And you have to check for extraneous solutions when you square, because when you square things, you get extraneous solutions. So that's what I'm using. So we have 2 secant x plus 1 now there's just one variable, so what I do is I get all the secants on one side, all the constants on the other. So you bring this secant over here and you just have secant left, right? And you take the 1 over here and you have 2. So remember that secant is what, 1 over cosine. So technically it's where cosine is equal to 1/2, right? So what values of x between 0 and 2 pi are cosine 1/2? Okay, pi over 3. Does everyone agree? Does that make sense? Okay, 16 then is going to be secant squared plus 2 equals minus 3 minus 1. So I just get secant by itself. This is going to be a minus 3. And then this thing you could just take the square root on this side, plus or minus the square root on this side. Secant equals plus or minus the square root of 3i. No solution, right? It's a complex number.
How do you plus or minus the square root of 3? You automatically know.
Well,
it's not going to fit anywhere. So
well, see this negative sign comes out as an I. So it's a complex number. And a complex number, you don't have any real solutions and real values of what we're looking for. So there's no solution. $18. That's cosecant x minus the square root of 2. Okay, what algebraic form would you do there? You got two binomials, right? When the product of these equals 0, then one or the other of them has to equal 0, right? So this says cosecant x equals a minus 2, and this one says cosecant x equals the square root of 2. Now, cosecant is what? 1 over sine? Just to help us try to figure out maybe where it's at. Well, 1 over sine. So this would be where the sine x equals what? Negative 1/2. And this would be sine x equals 1 over the square root of 2, which is, if you rationalize the denominator, I better start here. You do square root of 2 over square root of 2. So this is the same thing as square root of 2 over 2. So what values of x?
Well, for negative 1/2, you have 7 pi over 6, or 7 pi over 6.
Everyone agree? 7 pi over 6. 7 pi over 6 and 11 pi over 6.
And then for square root of 2 over 2, you have pi over 4, 3 pi over 4.
Everyone see it? You use your unit circle or whatever.
Yeah. Sometimes it's hard to.
Yeah.
I should have memorized that.
Yeah. Okay, 20. Says 2 cosine squared x squared to 3 cosine x. Okay, what do you think you're going to do with that? You have a common factor? Take cosine x out. And then you have 2 cosine x minus the square root of 3. Now what can you do? Set each factor equal to 0, right? So this one is cosine x equals square root of 3 over 2. So for 0 cosine x, it's going to be
pi over 2 and 3 pi over 2.
everyone agree? See, if you're using the unit circle, you look at the first term, right, of the ordered pair. Okay, the square root of 3 over 2.
Minus 3 pi over.
Oh, 3 pi over 2.
Was that for the cosine x equals 0?
Yeah. Okay. Okay, the square root of 3 over 2.
Oh, yeah.
What's the first place you get it? Where do you get it, Chris? Where's the first one? Where do you get the square root of 3 over 2 the first time when you go around the unit circle?
Pi over 6.
Okay, pi over 6, right? And then the other one is where? 11 pi over 6. Right? And once you get to this point, it's not too hard, but it's figuring these things out sometimes can be a little bit more difficult. Figuring out how to factor it or find it. So what do you think here? Move the 1 over here and get 0 by itself. And then that one, you try for trial and error, right?
Yeah.
So what you're going to do is you're going to go cosine x, cosine x. You're going to have a plus and a minus. That's what how you get this sign. And these got to both be 1s, right? But now 2 times 1, and the other one's 1 times 1, and the difference is 1. But what do you got to have? This 2 has got to be with this negative sign, right? So it's got to be back over here. Now what are you going to do? Set each one equal to 0. So this is cosine x. This is cosine x equals 1. So 1/2. Where's that? Negative 1/2.
One second. The first time negative 1/2 appears for cosine would be 2 pi over 3.
Okay.
And shouldn't there be another one?
Yeah, there is.
I just gotta keep going. Okay, so 4 pi over.
Everyone agree? 4 pi over 3. Okay, now Where does it equal 1? Cosine x. Cosine what? Well, see, the thing is it's between 0, including 0, to 2 pi, but not including 2 pi. So where is it 1?
Oh, that's the difference between bracket
Yeah. See, when they put this little square, they say you can include 0, then they go 2 pi, and when they put this, they say you can't use 2 pi. So what is it then?
0.
0, right? This would be at the beginning or at the 0 point. Because you can't use that 2 pi. It does occur at 2 pi, but you can't use it. All right, 24. Now notice that here what they're doing is they're doing 0 degrees to 360, but not including 360. 24 says tangent theta minus 1 cosine theta minus 1. They've already factored it for you, haven't they? So you set each one of those equal to 0. So this is tangent equals 1, and then cosine theta equals 1. Now, remember this is degrees. So where is it 1?
Cosine 1 would be 0.
Okay, what you can do is you can do sine theta over cosine theta. So it's where these two are the same. And they're positive. I mean, the result is positive.
45.
Okay, so it's theta is 45 degrees. They can both be negatives, right?
Yeah, 2.5.
All right.
Cosine would just be 0.
Okay, this theta here would be at 0 because it's 0 and it's out there at 2 pi, but 2 pi or 360 degrees, but we can't consider that. So what do you think about that thing? I think that one's pretty tough. I don't really know how to do the whole thing. Okay, that might be a way. But I can do this. And I can write this numerator as sine theta or cosine theta. And I can get this over common denominator. this has to be cosine over cosine. And then this one would have to be sine over sine. And then this one would be sine theta cosine theta over sine. And if I invert and multiply, so then this is sine theta cosine theta. Now, the problem is if I cancel these out and have tangent square root of 3, I lose part of my answer. And I kind of forget how I got to do that. But if this is 1, then you got sine. This gets me part of the answer, which is the same thing as square root of 3 over 2 and 1/2. So both of them have to be positives or both have to be negatives. So where does that happen? At 60 degrees, don't it? 60 is one place. Then 240. Yeah. That only gets me half the answer, and I'm not 100% sure. How I have to go about getting the other part. And it has to do with I'm canceling this out. So I'm losing something. But I can get part of it. Yeah.
Is there a value of plus 4, squared plus 1 and it's squared or something resulting?
Well, I could square both sides of this, but then I get tangent theta plus 1 quantity squared. This thing goes to 3, and then this is, and you don't have an identity. You have to take apart your thing to get the identity of like 1 plus tangent squared, which is like secant squared. And I don't know how to manipulate it to get it. I thought this one looked kind of tough, and worked on it a little bit, and I thought, man, I don't think I know how to do this one. Not to get it completely. I can get part of it, but I can't get. There's two more values, and it has to do with I know what it is. I know what it is. It's when I cancel this to get one, I lose part of my solution. Because you can't. And you can't say that this thing equals that. The only thing you can do is say it equals 0. So I'm just unsure. I didn't have enough time to take a look at it. 28. Here's cosine squared. Sine squared. What do you think you'd do with that?
Sine over cotangent squared equal to 1. Separate equal to 0.
So you want to do what? You want to divide both sides by cosine?
No, you can take sine. Sine minus. I'm thinking right home.
Well, this is what I would do. Then I could move this thing over here and this one over here. I could get 2 equals 2 sine theta. So that sine squared theta would equal 1. Right? And then if you took the square root of both sides, plus or minus the square root over here, then I'd do sine theta equals plus or minus 1. So you say sine theta equals 1 or sine theta equals minus 1. Where does it equal 1? Okay, 90 degrees. I guess that's the way I'd approach that problem. This, see if I add sine squared theta to both sides, then it's 1, isn't it? It's 0. You're right. So I got that. This should be 0. All right. Thank you. But then it's going to be 0. So then it's sine squared equals 0. Then you divide by 2. So now then, theta would have to equal what? 0, right? And 180. Okay. Which one? 2830. So sine squared cosine. Okay, what would you do there? Anyone have an idea? What would you try?
A little too much algebra.
If you, what? Well, I think this is what I would try. I guess when you divide by cosine, you lose something, like I lost that thing in that other problem, but you could do this. Then what could you do with that? Common factor it? Minus 1. And then you could do what? Okay, did I write it down wrong?
No.
Oh, it's not.
Yeah. All right. Now then, I would set each one of these things equal to 0. Now this one would be what?
90.
Yeah, everyone agree? And then this one equals sine squared theta equals 1. So sine plus or minus 1. So you'd have two things. Sine theta is 1 or sine theta minus 1. And is that the same solution?
For -1, like, put the wrong symbol in.
I think that's right. This one is 90 and this one is 270. Okay. 32. You could just set each one of those equal to 0, couldn't you? So this just says sine, when I do the square root of both sides, this says sine theta equals 0. So here's theta is going to equal, and then theta is going to equal,
90.
what do you think? Use your trig identities. Could you do it either one of these two ways? Just substituting 1 minus cosine squared. You could do 1 minus sine squared for this one. Then just run your negative sign through. So then you'd have 2 cosine squared theta minus 1 equals 0. and then just solve this for cosine squared. So equals 1/2. Then you'd want to take the square root of both sides, principal where plus or minus. And this would be cosine theta. This is the same thing as what? The square root of 1 over the square root of 2, which is the same thing as the square root of 2 over 2. Plus or minus. So where does it? The two things you'd have is cosine theta would equal a positive square root of 2 over 2, and cosine theta would equal a negative square root of 2 over 2.
Positive, you have 35 and 350.
And what did you say the other one was?
135. Oh, 315.
And this one you'd have,
135 and 2.5.
everyone agree? Is that right?
Yep.
These are fun, aren't they?
As soon as you do the first part, and look to do the identity
Yeah.
or factor or then yeah, I can actually say.
It's your algebra.
Well, okay.
What is it? Your algebra skills are not,
Yeah, not exactly up to stuff.
yeah. That's why technically you're supposed to take college algebra when you do this. So that you're very proficient in your algebra skills. But you're not gonna get any place because you don't have 0. You either have to move the 1 over and then try to factor it, but you're going to find out it don't factor, right?
Or cosine.
Maybe it will. No. See, if you try to do this, that won't factor. Because you'd have to do it trial and error. And 2 numbers times itself is, their difference has got to be 4, and you can't get it. Because it's got to be plus or minus, right? It will not work. Now, you can either write this way and use the quadratic equation where you'd go x, cosine theta is equal to a minus b plus or minus the square root of b squared minus 4ac all over 2a. And that's what they're suggesting in the book, where a is 4, that, b is 4, which is this, and then c equals minus 1. Or else I'm going to do it a different way. I'm going to do completing the square. You can do it this way if you want. And I'll move that 1 over here. I'll factor the 4 out. And divide the 4 into the other side. So I have cosine squared theta plus cosine theta equals 1/4 And then I'm going to do half the middle term. Half of 1 is 1/2 the quantity squared. And I've made this left-hand side into cosine theta plus 1/2 the quantity squared. And then this is 1/4 plus 1/4 is 2/4, which is 1/2, right? This is 1/4 plus 1/4, which is 2/4, which is 1/2. Then I take the square root here, plus or minus the square root here. Now, cosine theta plus 1/2 equals, and this is technically what? Square root of 2/2. Plus or minus. So I have cosine theta equals a negative 1/2 plus the square root of 2/2, and cosine theta equals a negative 1/2 minus the square root of 2/2. And I'm not sure that you can get that in your head. Nearest tenth as appropriate. So what this is going to have to be is this is going to have to use your calculator to get it. Theta is equal to cosine inverse. And this is going to be minus 1 plus the square root of 2/2. And then this is theta equals cosine inverse of minus 1 minus the square root of 2/2. So that's a calculator problem. Bracket. Better bracket. Double bracket that. 1, negative 1. Negative 1 plus. I got enough brackets. And I had the stinking thing in the radian mode, right? Mode. Now I go. I can get that thing down, can I? And then enter again. Is that what you got for that one? 78 something? Which number are we doing?
378, yeah.
36. Nearest. So 1/10 of a degree. So this one would be 78.0 degrees. Because it's a negative, no. but you said it came out undefined, huh?
You change the plus to a minus.
Cosine. Then you're gonna have to bracket it again. Put this minus 1 minus second square root of 2 bracket. Oh, I got divided minus. This one right here. 2. I got the right amount of brackets. It doesn't. What it is the square root of 2 is 1 point something. So you got a negative 2 point something divided by 2. So you got a number smaller than a minus 1, and there's no such thing as a cosine of any degree. Any degree equals less than minus 1. That's why it's undefined. You understand what I'm saying? This sum right here is a number that in absolute value is bigger than 1. You can't get that. Okay, so I guess I've done, you can look at the rest of those up through 276, and we'll look at 6.3 next Wednesday. I'm anticipating I'm going to be gone Monday. And I'm not sure that we're, oh, here. Shut this off.